In this video, we will talk about radiant measure and coterminal angles. So in the previous video, we talked about degrees. So that was an angle measure that we spoke about. And here we're going to talk about radians. So radians are used primarily in calculus. So if many of you guys are going to take calculus, we just use radians a lot in that class. If you're going to be taking physics, then physics, there's a lot of degrees. So you're going to be using a lot of degrees. But you should really know radians because, especially if you're heading into the calculus, all of calculus is based on radians when we talk about trig functions. So what exactly is a radian? So a radian is just, so an angle of x radians is an angle that cuts off an arc of length x on a circle of radius 1 centered at its vertex. So what does that mean? So if I have a circle, so let's say this is my circle, and then I have, here's my center of the circle. And remember, this is radius 1. Okay, so it's a circle that is either 1 meter, 1 inch, I don't know. So we have the circle. And basically what we say is that this is x radians if this guy right here, the length of this particular arc is also x. Okay, so basically that's what it is. So x amount of radians is an angle that cuts off an arc length of x. So if this guy is x, or the length of this thing is x, then this thing is also going to be, then this guy is x also. That's basically what a radian is. Okay, so we're going to prove how many relating radians and degrees. So use the circumference of a circle to show that 360 degrees is equal to 2 pi radians. Okay, so the circumference of a circle is basically c is equal to 2 pi r. So that's just a formula that we've learned in geometry. And remember that the circumference of a circle is just basically the length all around the circle. Okay, so think about it like the perimeter in like a triangle, right? So the length all around the circle is just basically the circumference. It's just a fancy way to say perimeter. So here, remember, radius is equal to r. Okay, so c is equal to 2 pi times 1. Okay, so the circumference is equal to 2 pi. Okay, well, that's one whole revolution, right? That's one whole spin. Well, that must mean that and what also is one revolution, one rotation? Well, 360 degrees is equal to 2 pi, okay? You kind of think about it like, so we just found the length of the whole circle. The whole circle is 2 pi. Well, remember that if this is 2 pi, then the angle itself in radians will be 2 pi radians, okay? So whole circle is 2 pi. Okay, whole circle is 2 pi. That means that the measure itself is also going to be 2 pi radians. Well, what's also one full revolution? Well, 360 degrees. So 360 degrees is equal to 2 pi. Okay, so 360 degrees is equal to 2 pi. Okay, now we need a conversion. So let's just divide this by 2 to make it a little easier. We have that 180 degrees is equal to pi radians. Okay, so this is basically going to be my conversion factor. Okay. All right, so let's go ahead and do a couple of examples to convert degrees to radians and radians to degrees. Okay, so we'll start off with the first one, which is 90 degrees. Okay, so let's convert the degrees to the radians. Well, we're going to start off with 90 degrees, and we're just going to convert it, okay? So the way that we want to do this, and maybe you've seen this in chemistry, when you do stoichiometry, and you'll probably see this in physics as well. So you want to be able to get rid of the degrees. So in order to cancel out the degrees, we should put the degrees on the bottom because then it'll cancel them out. So we know that there's 180 degrees in pi radians. So basically what happens is that the degrees cancel out and all you're left with is just radians. So you'll have 90 pi over 180, which is equal to pi over 2. What I want you to do, especially in exams, is make sure that you simplify this. Do not leave it and 90 pi over 180. Make sure that you simplify it completely. Okay, your calculator, if you have the TI-36X Pro, you can just use a fraction bar, which is a number right above, the button right above the 7. Just press that button and it'll reduce it for you as well. Okay, now let's do 120. So we have 120 over 120 degrees, and we're gonna convert this so we know that it's 180 degrees and then pi radians. Okay, so the degrees are going to cancel out, and you're left with 120 pi over, 180 degrees. Okay, so if I simplify this, I'm going to get 2 pi over 3. Now, notice that I haven't been writing radians. Whenever you have, you can write radians, pi over 2 radians if you want, but typically we just leave it as the angle itself, 2 pi over 3. We don't even write radians. Okay, now let's do negative 60. So we have negative 60 degrees. We're gonna multiply this by 180 on the bottom, and then pi on the top. So then this goes away. So you're gonna have a negative 60 pi over 180. Okay, so this is gonna give me negative pi over 3. Now notice that I'm not evaluating the pi as well. Don't do that. Just leave it in terms of pi, and you'll see that in a lot of the problems that we do here, we don't really want a decimal answer unless I ask you to do it. Okay, so just leave it like that. So here we can actually bring up a rule. So if you want to convert, so let me write it right here, to convert degrees to radians, all you got to do is multiply by pi over 180. So if you really want a rule to how to convert degrees to radians, all you got to do is multiply by pi over 180. Now, usually I forget it, so I just go ahead and just look at, okay, what do I have? I have degrees, so I got to put the degrees on the bottom. That's what I remember. I don't remember this rule. But if you really want to have this rule, you can have it. Okay, so let's look at this other one. So now we're going to convert the radians. So these guys are in radians. Now we want to convert it to degrees. So I start off with pi over 4. So what I'm going to do, since I have radians, okay, this is radians. So I'm going to have the radians on the bottom now. So pi radians, and I want to convert it to degrees, which is 180. Okay, so if you can think about radians being here, if you really want to, the radians will cancel out, and all I'm left with is the degrees. Now, notice that also, in addition, the pi's also cancel out. So you're just left with 180 degrees over 4. Okay, and this is going to give me 45 degrees. Okay. Now let's look at 5 pi over 4. You can write radians if you'd like, because radians is on the top. So you're going to have pi radians on the bottom is equivalent to 180 degrees. The radians will cancel out, and I'm left with degrees. So I'm going to take 180, multiply it by 4, and I'm going to get 900. Okay, notice that the pi's go away, and I'm going to have a 4 on the bottom. Okay, and then when I divide this out, I'm going to have 225 degrees. Okay. Now let's do the last one, which is going to be 7 pi over 3. This is in radians. I'm going to have pi radians on the bottom, and then 180 degrees on the top. The radians and the pi's go away, so I have 180 multiplied by 7. That gives me 1,260 degrees over 3, which is going to give me 420 degrees. Okay, now you're probably wondering, how can I get 420 degrees? Okay, if I only can get a maximum of 360. Well, you can always think about it this way. So here's my initial side. 1 full revolution is 360 degrees. But then if I go an extra, so like if I keep going, well, notice that now I have more measure. Okay, so you can continue going many different revolutions, right? So this is no longer 360 degrees, it's more than 360 degrees, okay? So basically, you can exceed 360 degrees, just like you can go down more or less than 0 degrees to negative degrees, okay? So, and here we'll give you an example. So sketch both angles, 330 degrees and 390 degrees, okay? So let's just try to sketch this guy. So let's say this is for 30 degrees. Okay, so this is gonna be 0, 90, 180, 270, 360. Okay. So the 30 degrees, if I think about it in terms of thirds, it's gonna be around here. Okay, so 30 degrees is gonna be around here. So if this is my initial side, 30 degrees will be about right there. Okay. Now what about 390 degrees? Okay, well, let's just try to do it. So we have 0, 90, 180, 270, 360. Well, 390, well, that's gonna, well, so first we got to do a full revolution. That's 360. Now, in order for me to get to 360 to 390, I have to add an extra 30 degrees. Okay, so I added an extra 30 degrees, and this guy is where it's going to stop. So all of this is going to be 390 degrees. Okay. Now notice here, what's similar about these two angles is that they all end at the same spot. So 30 degrees is in the same spot as 390 degrees. These angles, we call them coterminal angles. Okay, so coterminal angles share the same initial side and the same terminal side. Okay, so in other words, in order for me to find a coterminal angle, I have to either add or subtract by 360, because remember, you can still have a negative angle. You can add or subtract by 360 degrees, or if you are in degrees, or by 2 pi if you're in radians. Okay, so if you're in degrees, you're going to add or subtract by 360. If you are in radians, you're going to add or subtract by 2 pi. Okay, so, and notice here that if I take 30 degrees and I add 360 degrees, I'm going to get 390 degrees. So these two guys here are coterminal angles. Okay. All right. So here, let's do some examples. So find the angle theta that is coterminal with the following angles, where theta is between 0 and 360 degrees. So there should be a less than there. Okay. All right. So here's 800. So clearly 800 is not in this interval. So whenever you look at this actually should be 0 less than or equal to theta less than 360. Okay, because 0 and 360 are coterminal themselves. So notice that I want an angle theta that is in the same, has the same initial side and the same terminal side as 800, but it has to lie between 0 and 360 degrees. So here, 800 is way too much. So we need to subtract 360 degrees. Okay, so let's subtract first. So let's go to our calculator and take 800 and subtract 360. I'm going to get 440. Is this between this interval? No, 440 is still too big. It's coterminal to 800, but not yet. So now what we're going to do is take 440 and subtract another 360. So 440, subtract 360 again, and I'm going to get 80 degrees. This guy is the one that we want, because this guy is between 0 and 360 degrees, and is coterminal to 300, because we've been adding and subtracting 360. Okay. Now in this case, we have negative 40 degrees. Okay, so negative 40 degrees clearly is not between 0 and 360. So in this case, because we have a negative angle, it would make sense to add 360 degrees to it. Because if we subtract it, we're going to just get a bigger negative number. Okay, negative 40 plus 360 is going to give me 320. Is 320 between those two numbers? Yes, it is. So 320 degrees is my answer. Okay. All right, negative pi over 4. So now this guy is clearly in radians. Okay, so we're going to take negative pi over 4. Okay, so we're gonna add 2 pi in this case. Okay, so you can use your calculator and it'll give it to you the way that you want it. So you will actually end up getting 7 pi over 4. Now, let's say this is not, you're quite confused about how you got that. Well, another way that you can do it, so it's just finding the least common denominator. So remember that here, you have negative pi over 4. And you want to make the denominators the same. So how do I make 2 pi into the same denominator of 4? So if I have a 4 on the bottom, well, how did I change that? Imagine that there's a 1 here. So this 1 changed into a 4 by multiplying it by 4. So the top guy, I should also multiply it by 4, which is 8 pi. That gives me 7 pi over 4. Okay? Now, how do I know if this is between 0 and 360, because, well, one thing that you can do is you can convert 7 pi over 4 into degrees if you really want to. Okay, so you can do pi radians on the bottom, and then 180 degrees on the top. So you can do that if you'd like to. And if you do that, you're going to end up getting 315 degrees, which in this case is correct. Okay. Later on, when we start dealing with more radians, you'll kind of have an idea of like where exactly this is at. Right now, when you look at the fraction, it can be a little bit weird. Another thing that you can kind of think about is that I'll show it to you right now. Okay, so 44 pi over 9. Okay, so this guy is clearly bigger than 2 pi. This is in radians. One way that you can think about it is that if you go into your calculator and try to figure out what 2 pi is, 2 pi is going to be approximately 6.28. Okay, and if I put 44 pi over 9, you're going to see that this guy is going to be 15.36 radians. So you can see that this guy really exceeds the 2 pi. So you're going to have 44 pi over 9. Let's just subtract 2 pi. So you can do the least common denominator if you want, or you can just use your calculator. Make sure that it gives you in the fractions, because I won't accept any decimal answers on the exam. And this is going to give me 26 pi over 9. Okay, so if you were to kind of look at it in the calculator, you'll see that this is still bigger than 2 pi. So you're going to take 26 pi over 9, and you're going to subtract another 2 pi. Okay, so 26 pi over 9, and I'm going to subtract another 2 pi. That's going to give me 8 pi over 9. Okay, and if I look this up, this guy is clearly went below 2 pi. Okay, so the radians I think might be a little bit more difficult to kind of look and see, but that's just basically what how you do these problems. So just with a little bit of practice, you might want to have your calculator set also to decimal form so that you can kind of keep track of it. Or another way that you can do it is just convert it to a degree, and then degrees sometimes can be a little bit easier to look at.